So let's talk about asymptotes. Okay? Very exciting conversation on your first date. So what do you think is the point at which we're getting towards but never will get to in our relationship? And if she says the asymptote of love, then you can marry her.
Oh my goodness.
Who comes up with these jokes? Seriously. Okay. So finding vertical asymptotes is pretty straightforward. Okay? They're imaginary lines that the graph approaches as y becomes really large. Right? And just to show you a picture of that again, as I go to positive infinity for y and negative infinity for y, I start to approach my vertical asymptote. Okay? So that happens as y becomes really large. How do you find those vertical asymptotes?
Can you follow the shifts and the stretches around?
You could follow the shifts and the stretches. There's an easier way.
Graph it and take a look.
Graph it and kind of eyeball it. That could help you at least gain a suspicion. But you'll notice, just to help a little bit here, the non-permissible value and the asymptote are the same value. Right? Same thing happened in the last example. The non-permissible value and the vertical asymptote are the same. Okay? So that's how you find vertical asymptotes. Okay? They are the non-permissible values of x. So those are pretty simple, and you've done lots of that by now. Horizontal asymptotes, however, are a different beast altogether. Okay? These are imaginary lines that the graph approaches as what value becomes really large? Last time it was y, so this time it's probably x, right? And you can see that in the graph, right? As I go out to the right really, really far, the graph will approach the horizontal asymptote, and as I go to the left really, really far, the graph will approach the horizontal asymptote. Finding these values is not always simple. Okay? I'm going to show you a few ways of thinking about horizontal asymptotes. Okay? Because there are some different ways of finding them. So, first method I'm going to show you is understanding just the big idea of what's going on here. Okay? It's easier to detect what a horizontal asymptote is as you make x really, really, really large in your graph. Okay, so let me give you an example of what that looks like. If we use the function 4x minus 5 over x minus 2, can you tell me the horizontal asymptote of that function? You can tell me the vertical. What's the vertical? 2. But what's the horizontal? Can you tell what the vertical translation was here? No. The graph is not in this form. Right? It's not in this form. So it's hard to detect what this value of k is, because there's no constant out by itself. Right? The constant is still stuck inside the fraction. And even if you split the fraction, 4x over x minus 2 minus 5 over x minus 2, you still don't have a single number by itself. You see the problem? So how do you know? How do you know what that horizontal asymptote is? Okay. One thing you can do is you can take a really, really large value for x. Just try it in your calculator. Take like 100, I don't know, just put like 10 zeros after it. And store that as x in your calculator. You guys know how to store, right? Okay, just put a really, really large number for x. And then after you do that, input this into your calculator. 4x minus 5 divided by bracket x minus 2. And that will come out as, you got 4? Anyone else get something different?
Yeah.
What'd you get?
Got like 3.9999.
3.9999?
No,
What'd you get?
Have a point though.
4? So approximately 4. Okay? That at least should give you some suspicion that this graph is approaching y equals 4 as x goes really, really, really large. Right? You can even go in your calculator and graph that function. If you go in your calculator. So if you go in your calculator and you put in the function.
Is that the Windows recording right now?
Yeah. The blinky blink. Yeah. 4x minus 5 divided by x minus 2. And if you just take your window and make x go really, 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 really big. So 1, right, and then just graph it. Okay. If you trace and just move your cursor along, what do you notice the value of y to be? Yeah, it's 4. It's still an approximation, but again, that should give you some suspicion that the graph is approaching 4 as x gets really, really large. Right? If I chose a value of 1 for x, you'll notice that y is not 1. Right? But as I go further, oh, it's so scaled so awkwardly. If I chose 3 for x, still not 4. 5 for x, 6, 7, 8, right? For pretty small values of x, it's a little harder to tell. But for really, really, really far out, it seems like the graph is approaching y equals 4. Does that make sense? That's not an official way to determine a horizontal asymptote. That's just kind of like a, I'm going to use the best guess I can find to find the horizontal asymptote. Okay, so that's one way you can do it, is just make x really, really big, put it in, and see what the graph kind of equals approximately. Right, so here the horizontal asymptote would be approximately y equals 4. That's our suspicion, at least. We haven't proved it officially, but we can suspect that. Just try it again for another function here. 2x plus 2 over x minus 4. If you look at this function again, can you tell what the horizontal asymptote is? Just from the graph, or from the equation? It's a little tough, right? You know the vertical, it's 4. But the horizontal, again, put in a really giant number for x. Okay, so put in that same huge number for x. And then put it into the expression. Put in a really big number for x. And then put that into your calculator as 2x plus 2 divided by x minus 4. Okay, and you get how much?
I got
2? Okay, again, this is an approximation because it's technically not exactly 2. But we could suspect that the graph is approaching 2 as x grows really, really large. Right? So we would say probably the asymptote is y equals 2. Again, not an official method, but it gives you an idea.